Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about LXD IPVlan. But first, I want to review a few things about Macvlan and bridging. So we've discussed bridging and Macvlan for LXD containers in prior tutorials. A Macvlan profile in LXD allows you to get a DHCP address on either your LAN or on a VLAN for a LXD container. Macvlan provides a different MAC address for each LXD container, and most NICs and some switches actually have a limitation on the number of MAC addresses that they can support natively. A Macvlan container is not allowed to communicate directly with its LXD host parent interface because of security in the Linux kernel. So Macvlan does not work on wireless interfaces that use WPA2 or WPA3 because no more than one MAC address is allowed on a host wireless interface. So why would you use IPVlan? Well, LXD IPVlan containers have the MAC address of the parent interface and also all LXD containers. So that means you could have 5 LXD containers and all 5 of them would actually have the same MAC address. And that might sound like a disaster for your DHCP server, but some DHCP servers can deal with that just fine by using the client ID as the unique field. So IPVlan uses statically assigned addresses for each LXD container defined via a special LXD profile that we're going to review. Each IPVlan container will have its own LXD profile as a best practice. And Macvlan and IPVlan cannot be used on the same parent interface at the same time. So when do we want to use IPVlan instead of Macvlan? Well, if you have a host with a parent interface that is wireless, a wireless LXD server instance could use IPVlan, but I really don't advise a wireless interface for your LXD instances. In fact, I really don't recommend a wireless interface for any server instances because it doesn't provide the level of availability and performance that you're normally looking for if you have a served self-hosted application. So if your parent interface performance drops because you've exceeded the maximum number of MAC addresses, that might be a reason why you would want to use IPVlan. And if your physical switch limits the number of MAC addresses that are allowed on a particular port. So my thoughts are use the bridged interface first if you're going to go to your main LAN. Use Macvlan second. Sometimes I even use Macvlan first, depending upon my use case. And then use IPVlan last if you need it for your application. So the real thing here to avoid these problems is to buy network interface cards and switches that can handle multiple MAC addresses. So here I've drawn a very simple diagram where we have the public internet connected to a router, a local area network of 192.168.1, and we have 2 hosts on this, and they're both LXD hosts, but the host that's at 192.168.1.50 is a host that's going to use LXD containers that use IPVlan profiles, whereas 192.168.1.55 is a LXD host that's using Macvlan profiles. And you notice in both cases, the IPVlan and the Macvlan containers, of which we have 3 on each, all have different IP addresses as you would expect, But the difference is on the IP VLAN, you notice that the MAC address for the parent is the same as the MAC address for the first container, the second container, and also the third container. Whereas on Macvlan, we have different IP addresses on each of the containers, but the MAC address for the host is different from the MAC address for container 1, which is different for container 2, and different for container 3. So this is a pictorial way to explain exactly how this works. Let's start by creating a new LXD container called test. We hit enter here, and it's going to go ahead and launch an Ubuntu 2204 container called test with the default profile. So it's going to use an internal NAT address, and we have boot.autostart equals to true, which means that when this LXD host boots, it will automatically start the container. Now if we take a look at the container with the LXC list, we can see that it has an address of 10.230.26.157, which is on the internal NAT network. So if we do a LXC profile list, we only have the default profiles so far. LXC profile create IPVlan creates the new IPVlan profile that we're going to use here shortly, and then we're going to go out and do an edit of that profile with the LXC profile edit IPVlan, and then I'm going to use a Control K to delete everything in that file. Next step is going to be to paste in the new profile, which I'll include in the show notes, and that profile includes the following information. Inside of the container, we're setting the internal device ETH0 to have the address of 172.16.2.2, which is an address inside of my network on my main LAN, but not one in the DHCP range. The name servers are set to Cloudflare at 1.1.1.1 and 1.0.0.1. The routes are basically saying we can route through anywhere through the auto configuration address. Those are really not being used per se, but then the onLink equals true is required to bring that link up and get it running. And then the real part of the profile is really the IP v4.address is 172.16.2.2, where the NIC type now, instead of MacVLAN, is IPVLAN. My parent Ethernet device, by doing an IP config, is ENP5S0, and of course it's type NIC. So I do a Control X, and I finish that. So if I do a LXC list profile, we now have, LXC profile list. We now have two profiles. We have the default profile, and we have the IPVLAN profile. Even though I've hard-coded an IP address into that profile, IPVLAN, I want you to consider it to be a template. And so I'm going to do a LXC profile copy IPVLAN over to IPVLAN underbar 172.16.2.2, which is the address that I'm using. And again, just to remind you, if we go in and we edit that VLAN, you're going to see that it is everything that we put in previously. But had this been a template that we just copied over, then we'd want to go down here and make the appropriate changes to things like the IP address, and then also to the parent device if that was not ENP5S0. So in order to apply this to our container that we created, we simply do a LXD profile add test IPVLAN underbar 176.16.2.2, and when we try to do that, we're going to get an error which says you failed to modify ETH0 device inside of the container. So we'll have to do a LXC stop test, and then we can do a LXC profile add test, and then we can do a LXC start test, and the container will start back up. Now if we do a LXC list, you'll see that the container is running at 172.16.2.2, which was our intention. If we do an if config on the LXD host, we can see that the MAC address of EMP5S0 ends in BD5D. And now, if we do a LXC exec to test Bosh, and then we do an apt update, which we should always do with the brand new container, you can see that it's getting its updates from the net fine, so that means that its networking is working correctly. And we'll do an apt install net-tools, and we'll clear the screen, and we'll do an if config again, and you can see that the address is 172.16.2.2, but we have an MAC address of BD:5D on the end, which means it's the same as the LXD host, which is kind of interesting, but that's how IPVlan operates. So now I moved out to another host on the network, and we're going to do an SSH over to 172.16.2.2, and my account here on this system is named Scott, and so it is also on the remote system because I created a Scott account on the LXD container. If I hadn't, I would have to say SSH Scott at 172.16.2.2. It asks me whether I approve the authenticity of the host. I say yes, and then I type in my password, and I'm logged in. So I'm logged into my LXD container, but this is a LXD container that's using IPVlan. Again, if I do an if config, you will see that we have device ETH0, but ETH0 is using device BD5D. Here we have a LXC list that shows that I have the one VM called test running at 172.16.2.2 with IPVlan. We have our template IPVlan, and we have our IPVlan that we're using for that particular container called test. Now, if we want to create a second container that also uses IPVlan, we'll go ahead and do a copy command, and we'll copy the IPVlan over to another IPVlan called IPVlan underbar 172.16.2.3. Now we do a LXC profile list, and you can see that 2.3 there, and then we'll do a LXC profile edit on that particular profile 2.3, and we'll go in here and change the 2.2 address to 2.3, and we'll go down here and we'll change the 2.3 address down here to 2.3 also. Of course, the parent interface stays the same at EMP5S0. I go ahead and exit that. Then, in order to create a new container, I simply do a LXC launch on test 1, we'll call it this time. Creates the new container, remaps the file system. We've already learned that we need to stop it, so we're going to do a LXC stop on test 1. Here we can see that the test 1 container is stopped, and if I do a LXC profile list, you can see the new container, or the new profile, is IPVlan underbar 172.16.2.3, and in order to apply that to our container, we do a LXC profile add test1 IPVlan underbar 172.16.2.3. After we do that, we say LXC start on test 1, and then we can do a LXC list, and you can see that we have test and test 1 running there. If I do an if config, you can see that the host ends in a MAC address of BD5D. If I do a LXC exec on test 1 with the BOSH shell and do an if config, and we can see that 172.16.2.3 test 2 also has the same MAC address of BD5D. So normally having the same MAC address in multiple places on your network is a bad thing, but that's kind of the design behind IPVlan for the reasons I mentioned. So in summary, it's important to understand IPVlan and its use cases. So it's just another type of networking that we hadn't covered before. We've covered bridges and we've covered Macvlan extensively. So not all infrastructure devices can effectively deal with the same MAC address on multiple container instances. And that's one of the reasons why I had not covered it up until now. Macvlan is the preferred solution, and that's why I've covered it on the channel extensively in the past. In fact, if you look around, you'll see that I probably have in excess of 40 videos that refer to different features of LXD containers using Macvlan. So whether you use Macvlan or IPVlan, be sure to manage both your MAC addresses and your IP addresses on your network for effective operation and security. And I believe I've mentioned before that I believe a best case or a best use case would be, or best practice is the best way to describe it, is to always perform your address management at your router and not on individual instances. So setting addresses or static addresses on individual server instances, once you end up with a lot of them, kind of creates a management nightmare. And by managing all of your address instances up on the router, you can be assured that you're not going to have conflicts, and plus you have a single point of management. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.